Hello everyone, we are going to see refraction at concave spherical surface. So we are going to see the phenomena of refraction, how it takes place in concave surfaces. So to make a diagram, see here very carefully. This is concave spherical surface. See the principal axis. Let it is rarer medium and this is denser medium. The refractive index of rarer medium consider N1 and denser medium N2. Let a point object is kept here at this point P. This is object O. Because we are always taking object in left hand side. So before make a ray diagram, first let us see this line is called principal axis. This is principal axis. This point is called P. And center of curvature is called here C. CP is radius of curvature. CP. Radius of curvature. It is on left hand side. So it is sign convention is negative. Now we are going to take a ray diagram here. Is here. Let it meets at point A here. So where it's meet, it is required to make a normal. So what is a normal here? Normal always passes from a center of curvature. So take a dotted line. This is a normal. Rarer medium is here, denser medium is here. Ray of light, when it is passes from rarer medium to denser medium, bends towards normal. So let this ray of light bend in this side. This angle is called angle of refraction R. Naturally this angle here, this side is called angle of incidence. So to make a image, proceed this line forward, backward here. It seems to pass here. This is point of image here. So now and join this point here. Take here point A and this point is M. Now see very carefully here in this diagram. OP, distance between object and pole, is denoted by U and it is in minus sign because it is in left side. Image is also formed on this side. From image to this V. So image distance IP is also minus V. The angle, some angles we are going to decide. Incidence angle make alpha angle with the principal axis. Image make beta angle and normal makes gamma. Let alpha, beta and gamma makes make angle with principal axis of incident ray, refracted ray and a normal. Now see carefully what are the steps required to obtain here. So for the step, see carefully here in this box. For I, see this is angle I in the diagram. This is angle I. Angle IC, angle R. Angle I and angle alpha. And this gamma. We are going to take first of all triangle OCA. OCA. Sum of two interior angle is third exterior angle. So what is the interior angle here? Alpha plus I is equal to exterior angle is gamma. By this relation one may obtain I is equal to gamma minus alpha. We are going to take it as equation number 1. This is value of I. Now see, we are going to take for the R you see here R. This is angle R, right? So for angle R here, what is required to do? R is equal to gamma beta and gamma we want to see. We are going first of all select triangle. We are going to take triangle ICA. ICA. This is angle beta. This angle is vertically opposite angle of refraction R. So sum of two interior angle is third exterior angle. So in this we may write beta plus R is equal to gamma. Beta plus R is equal to gamma. This implies that R is equal to beta minus gamma. This is equation number 2. This is beta minus gamma naught, gamma minus beta. Now Snell's law speaks. We are going to take a value of Snell's law, that is n is equal to n2 by n1 is equal to sin I by sin R. So third equation we are going to take for the Snell's law, that is refractive index n is equal to n2 by n1, it is equal to sin I by sin R. See here in the diagram, if A is close to M, then these angles are very small. I and R is very small. Here A is very close to M. Although it is in diagram, the wider distance is located, but really this distance is very less. So in that condition, I and R is very small. So at this situation, angle I and R is very small. If it is very small, then sin I approximately can be written as I and sin R approximately can be written as R. Under these circumstances, equation number 3 can be written as n2 by n1 is equal to I by r, or this implies that n1i is equal to n2r. This is equation number 4. Now, in equation 4, it is required to keep a value of I and r from equation number 1 and 2. So, now putting the values of I and r in equation 4. So equation 4 can be written as n1 I. I is gamma minus alpha is equal to n2. It is gamma minus beta. Now open the bracket. n1 gamma minus n1 alpha is equal to n2 gamma minus n2 beta. So beta and gamma we are going to keep one side, alpha and beta in one side and gamma is on another side. So this becomes n2 beta transfer this side, minus becomes plus, n2 beta minus n1 alpha is equal to transfer n1 gamma that side. It becomes n2 minus n1, taking gamma as a common. This is equation number 5. This is n2 beta minus n alpha is equal to n2 minus n1 gamma. Now this is time to obtain the value of alpha, beta, gamma and to keep in the equation number 5. So to obtain the value of alpha, beta, gamma, once more we are going to move in the diagram. This is alpha. We are going to take triangle OMA, AOM. Tan alpha is equal to AM by OM. So in triangle OAM, tan alpha is equal to AM by OM. This is equal to, again see in the diagram, AM take as a H. So AM by this side, take MP both as a common point because this distance, this is very short, so both point is much closer to each other. So we will take M and P as a single point. Under these circumstances, this distance becomes equal to minus U. Here all are negative in sign. So it is minus H by U. Since this is very small, so tan alpha can be written as alpha. It is minus H by U. Similarly, to obtain for beta, we will go in triangle IAM. This tan beta is equal to AM by IM. AM by IM tan beta. Since AM is equal to H and IM is minus V, and if beta is very small, tan beta can be written as beta. It is minus H by V. Let this equation is 6 and it is 7. Similarly, for gamma angle, we will take triangle CAM. In that, tan beta is equal to again AM by MC and it is H by minus R. See in the diagram, AM by R here. This implies that gamma is equal to minus H by R, equation number 8. Now, what are the steps required to do at this stage? The value of alpha, beta and gamma is determined. This is time to keep the value here in equation number 5. Here is N1 alpha, and alpha we have determined H by U with minus sign, plus N2 beta. Beta is H by minus V. Since equation 5 is N2 beta minus N1 alpha is equal to N2 minus N1 gamma. So N2 beta is minus H by V minus N1 alpha is H by minus U is equal to N2 minus N1 gamma. It is H by minus R. See here in this hole, H is available everywhere and can be cancelled. So it is minus N2 by V and minus minus plus N1 by U is equal to N2 minus N1 by minus R. Now change the sign. N2 by V minus N1 by U can be written as N2 minus N1 by R. This is the required relation number 9. By using the relation number 9, we can obtain the relation among all four quantities here, U, V, R, and refractive index N, which is equal to N2 by N1. So this is for the topic. Thank you and have a nice day to all.